Hello, everyone. Good to be here. Great event we had so far. Today, we're going to see the lessons learned inserting augmented reality into IKEA's mobile landscape using the new feature called Unity as a Library. My name is Jefferson Scomacao, AR Lead Manager at PTC. Before we start with the Unity as a Library feature, it's important to understand IKEA and IKEAPlace. IKEA, one of the biggest furniture retailers, released in 2017 an application called IKEAPlace, their first augmented reality application developed with ARKit. I was there. I am the one that pushed the button for the first release. The IKEAPlace set the standards for retail applications regarding AR. And IKEA liked so much the concept, so much the user interaction and the response from the customers, that now they want the same feature, the same look and feel, the same performance, the same content distributed across their franchises. For this, we used Unity as a library. So, what is Unity as a library anyway? This new feature, present also in the keynote, is the ability that you can export your project and encapsulate inside another native application. This gives you the freedom that you can redistribute your application across multiple other native applications. Today, we are going to focus on the iOS version because IKEAPlace changed to the way to use the Unity platform, and for now, only on the iOS. Let's start a little bit how the Unity as a library works. Now, when you start a new project with Unity as a library in mind, you start with your Xcode project. Inside your Xcode project, you have a workspace, standard procedure for any Xcode project. Inside your Xcode project, we are going to have two separate projects. One that is your host application, your native application that you want to create, or a pre-existing application. On the other hand, we have your Unity as a library, compiled application that is a binary, is a compiled project that is your Unity project encapsulated into iOS build. To make all this work, we, developers, need to create a communication layer between these two projects. This work makes possible for you to have your AR, your Unity 3D part, and your native part working together. The result of all this is a single application, and for the end user is a seamless integration. Moving forward, on the Unity perspective, it's important to note that there are a few differences now. When you start an iOS project using Unity, you make the build, you generate an Xcode project, and now what is different, if you open your project, you are going to see Unity framework. It's a new framework that's generated for you on the Unity 2019.3. This is the link between your Unity project and your native project. Inside your Unity project, you are going to have a little bit of code that makes the communication possible with the other side. That I'm going to explain a little bit later. On the native perspective, the native perspective will have minimal changes. When you add your Unity project to your workspace based on your native application, the only thing you need to link is one embedded framework. We can see on the number 1, your native application, and right below, your Unity framework that you can add based on your Unity built project. For the developer, this is everything you need to do on the Xcode to make the integration, besides the coding. The combined perspective of your Unity project plus your native project will be seamless even for the developer, because the compiled Unity project becomes one view. In this case, we can see here screenshots from the IKEAPlace 4.0. IKEAPlace 4.0 is the first IKEA mobile application that uses Unity as a library. In this case, the whole UI is made on the native side, on the native application. And everything that we know about AR from IKEAPlace is encapsulated into the Unity as a library and set here. When we want to display the AR feature, we just initialize the view from Unity. And it's simple like this. Now that we see the integration, it's important to understand a little bit of the flows we have around the Unity as a library. We have a new set of features and some challenges that I saw on some developers having difficulties to understand how to track your new project using this new feature. It's important to note that all procedures that we're talking here today from the Xcode perspective are standard procedures. This is another change that Unity as a library brought to us developers, that now everything that we do for the exporting Unity as a library from your Unity project to the full integration into your native application follows all Xcode standard procedures. There is nothing different than any other framework you use from any other third party you have used before. The new workflow now is split in two because we have one Unity project and one native project. In this case, it's recommended that we split your code in two repositories, one for the native part and one for the Unity part. Why is that? Keep the separation of the teams, the features, and easier to track changes on repositories. On the Unity side, the build process is the same. You just build and it outputs your iOS project. You can run also in standalone mode directly from this build or integrate as a library in your native application. It's important to note, really important to note, that all test procedures, all debug processes should be done on your Unity project. Everything must be validated before you do the integration. And this is the same for the native application, because once you have your integration with the Unity library, it becomes a binary, make your life a little bit harder on the part for debugging and testing. Because after the integration, you are going to test the native application. You are going to test the integration process. You are going to debug the native code. In this case, you should not try to debug the unit part because it is already compiled. This will make your life quite difficult. Having said that, I saw from many other developers some difficulties regarding the Unity as a library as a new feature. In this case, we know the recommendation from GitHub, Bitbucket, or any other repository regarding tracking files. This is the common approach for any repository. When you push your source code, you should not push builds. You should not push binary data to it. This makes your life difficult. You lose time and creates a lot of overhead managing these binaries inside your source code. I saw many developers pushing the Unity as a library binary into their native project source code. This is not the way to go, because once you try to make any kind of integration on your local machine or any build server you may have, it's important always to use the source code instead of the build binary. So you have always the latest features for you. In this case, you can see that for a simple integration, we should start with the Unity part. We pull the code from a repository for the Unity project. We build the iOS project. We pull the native application. We build the native application. Of course, to make the integration possible automatically, we need to create certain scripts, Python or Bash, whatever you want to use, and then you build your solution, but always based on the source code. If you need to distribute your binary then it's another story. Then we need to create our own repository only for the binary to distribute as a full runtime. Having said that, it's important to understand now how the integration works under the hood. Here, we are discussing only the iOS part. On the Android, it works almost the same, or the concept is basically the same. And for the unit communication with the native and the native communication back to Unity, there are a few steps. First, let's check the Unity to native information flow. In this case, we need to split the information in 3 steps. For who already created a plugin, anyone here created an iOS plugin in your life? A few people. So these guys know what is this. So in this case, that we need to send information from Unity to your native application, to your front-end application. We have 3 steps. One is in your C# level. That uses the standard external calls. Nothing different from any other plugin. Pretty standard procedure. On the Xcode side, we have the same signature for the method on the C level that you receive your call on the native side. But this part of the code still is inside your Unity project, on the plugins iOS folder, for example. The second step, from your C code, you need to define a protocol. You need to expose a protocol that other classes can extend and receive the calls from the methods you want. In this case, this protocol that I have here, native calls protocol, is defined inside my native part, inside my Unity project. Why is that? Because this is the flow of information. We need to subscribe to this protocol inside the Unity side to be able to communicate between both parties. And the last step to send information from Unity to C level, now to the other side, to your native application. On your native application, you are going to have your classes. And you can extend this class with this new protocol. There is some code here that you need to perform, that is not for today, that makes all the connection together, but the basic is you need to extend the protocol you defined on the Unity side on your native side. This makes your life easy to track and receive messages and commands from the Unity side. By the way, this is one of the approaches, okay? So there are other approaches that are more complex if you need more data to be transferred or more complex structures. Sending information from native to Unity is even simpler. In this case, Unity framework, that is basically your binary that you attach to your Xcode project, contains already commands for you to use out of the box. This binary that you create using Unity as a library is added to your Xcode project and a reference for your native application. In this case, for your native application, we have the send message command. This is also available for any plugin we created in the past with Unity. So send a message to go with name. This is the command they have for us to use. Straightforward, simple. If you need to send more information or more complex information, I strongly suggest to use pointers. You transfer a pointer to the other side and load the memory on the other side. This is a little bit more complex. We can discuss this another time. From native, when you call this method in your Unity part, we are going to have a game object with a certain name, and this game object with certain script with some method name. Basically, the plugin flow we had before, but now with a proper names and proper libraries to do this. And this one now is the whole flow combined. The whole flow of information for Unity, from Unity to native and native to Unity, all combined here. You can see the separation of details here. Inside our workspace, we have Unity framework and native project together. Each one is responsible for certain parts: unit framework, protocol definition, and registering the classes that you want to extend the protocol you defined. On the native side, extending the classes and receiving the methods you want to have. And on the native side too, send commands back to Unity, back directly to Unity side. After you see this the first time, sounds a little bit complex, but in fact, it's pretty simple, especially because now Unity provides us with standard integration procedures for Xcode. Everything that we mentioned here on the Xcode side is standard for any other framework anyone else created before. Having said all that, now we can understand how and why IKEA wanted to use Unity as a library to boost their IKEAPlace application. A little bit of history here. Before IKEAPlace 4.0, that was released this Monday, using Unity as a library, we had IKEAPlace as a Unity project deployed directly to the Apple Store. Then, IKEA wanted to encapsulate the augmented reality feature and deploy this to other franchises. Now it's possible because the project organization makes this feasible. IKEAPlace is split in 3 main parts: the native application that is composed by the UI and other features on the native side, everything that is related to the augmented reality, I mean everything, is encapsulated inside Unity. And of course, other libraries, other frameworks that compose the final application. And from there, we can distribute easily to other franchises. IKEA is a really big company. They have different franchises with different IT teams. If they try to do this themselves one by one, they would have different look and feel, different approaches, and repeated code. And the content that is the most important part for the augmented reality applications would be different from each franchise, because each one has a different focus. They try to sell different products in different countries. This way, IKEA can control who uses, how they use, and see the performance for each market. Super interesting how IKEA did it, but also important to understand how we can use this in other ways. What are the other opportunities we have here? What is the benefits we can extract from this new feature, Unity as a library? The first approach we have here is the basic case for IKEA. We have Unity as a library encapsulated into other projects. We can distribute to other projects. It's your own projects, customer projects, you name it. In this case, also is worth to mention that virtually all Unity features can be encapsulated. Remember that Unity, when builds the project, is, again, a native project. So everything you create natively and you put in your unit project, you'll be useful again in your distribution on the Unity as a library. So you are free to try all kinds of encapsulation the way you see fit. The second approach is not about redistributing the code. It's about make your application better. In this case, we know certain features are better or more available into the native side than only using Unity. Let's take the basic example, UI. Unity provides a good UI, but it's a multi-platform UI. There are limitations, there are hiccups on there. And the native UI, both on Android and iOS, they have lots of features. They have specific features per device, per models. And the look and feel of the UI on the native side is better than the multi-platform UI we have in Unity. This makes sense if you have application using a lot of UI, lots of pages, views, input fields, multi-language scenarios. your life is way easier on the native side. You encapsulate your game, for example, in Unity, universal random pipeline, augmented reality, virtual reality, name it. You can encapsulate everything you want and use the best of both sides at the same time. For the last, but not the least, this is my favorite. Unity is a library. Outputs for you are runtime. This means that it is valid to understand as a final application. In this case, you can think of new methods of monetization and how to sell your product to other vendors. In this case, the Unity as a library, you are going to embed this into other applications. One of the main gains into this is that you are able to introduce Unity features into pre-existing applications. Big companies, big applications, they often will not allow you to touch, to change their applications. But they are willing to integrate a new framework. So in this case, Unity is the perfect combination because we can integrate, we can monetize in different ways without recreating projects already running from zero. Another way to monetize, new ways of monetizing your projects is regarding licensing. So now that you have a plugin that you can sell to others, you can find different ways to monetize this for your company, for your work. In this case, you can imagine that I have one plugin, I have one Unity as a library, and I can sell for multiple people with different features, enabling, disabling the features based on the customer. This makes another possibility, not that it's better or worse, but it's one extra possibility for monetization inside Unity. For today, it was a little bit short, I know. For today, we learned how IKEA reduced the costs of the development for augmented reality applications inside their ecosystem. We learned that there are other possibilities regarding Unity as a library, and we saw how it works a little bit under the hood. Today, I will be at the Vuforia booth for the remainder of the event, and I need to say a special thanks to Twnkls team, IKEA, and Space 10. And you can reach me at my email, jraulino@ptc.com, or website, twinkls.com. Thank you very much, and we have 2 microphones for the questions. Thank you very much. Yeah, hey.
Hi. So traditionally, Unity normally overrides the app delegate for engine initialization. Is there any performance difference between using it as a library versus overriding the entire app delegate?
Yeah, in this case, the app delegate is not overwritten.
Yeah.
Because you initialize your native app delegate. And from there, you initialize the Unity view in separate. The performance level between the current build process as a standalone is the same as Unity as a library. It's the same application. We have it both in the same way inside the Xcode.
Yeah, sorry. I mean, are you initializing the engine when you create that view, or are you still initializing it at the startup of your app?
Now, you can choose when to initialize.
Okay.
On the native side, you can initialize at the start of the application, as if you have like a IKEAPlace, for example. If you have something that is like an e-commerce application that you want to initialize later, you can initialize whatever you want, and of course remove from memory and save some memory.
Okay, cheers. Thank you.
Yeah. Have you explored using Unity as a library inside of cross-platform frameworks such as PhoneGap and stuff like that? Is there any problems with that?
Can you please repeat?
Have you explored using Unity as a library inside of, say, PhoneGap for cross-platform development?
No. in this case, Unity can output Unity as a library for iOS, and you can integrate on the PhoneGap for iOS, because it's a framework. So if your PhoneGap build can use frameworks, or React Native, or Ionic, you can use the Unity as a library.
Okay, thank you.
Yeah. Cool.
Hi, thanks for the talk. I have two short questions. The first is we've seen the communication between Unity and native Objective-C in this case.
Yeah.
Have you tried, or do you know of any way to bridge that into Swift as well, or is it just Objective-C?
Yes, it's the same procedure. You just need to translate your protocol to Swift. So it's a pretty similar integration.
Yeah, makes sense. The second one is Android supported at all, or is there another reason why you're not doing Android yet?
Currently, we have 2019.3 supporting both iOS and Android on beta already.
Okay, it's good news. Thanks.
Hi, two questions as well. First, can you elaborate on Android? So I know Unity is just outputting an APK when I build normal. So do I have to make a custom Gradle project or something like that?
Yeah.
And the other one is, when the library loads, is it actually like stalling the main thread of the host application, or is it like asynchronously loading and you can like move on in your host application?
For the first question, the Android integration is pretty similar, like the iOS. The difference is the output of the Android version is Google project. You have a Gradle project there, and you need to create a proxy class that in this case we call protocol here, but on the Android we call proxy class because it's just extending the Unity player activity, and from there we can do whatever we want inside our project. And integration is also really similar. We need just to assign new package to the Android side. The second question was about?
Second question was, is it on the main thread? Is it loading on the main thread in the host application, and is it the complete application is stalled when Unity is stalled, or is it asynchronously loadable?
Is in the main thread.
Okay.
As a matter of suggestion, this is also more in depth. When loading Unity as a library, the suggestion is, as an Android application, load empty scene first. Mm-hmm. And then it's a really small footprint. The modern device even don't see the hiccup on this side. And then from there, additively load your assets, scenes, and so on. So make this progressively loading because it's on the main thread.
Okay, thanks.
Hi, my question is about debugging the Unity part. I guess it's still possible to build your Unity project for, like, as a standalone app and test your Unity content on the device to debug it there?
Yes. So from Unity editor, you press build. The output for iOS will be your Xcode project. It can run as a standalone mode, as a normal application you had before. But inside this Xcode project, you have your Unity framework that you are going to embed this into other native application. So you can make the connection between the two. So you can run both modes. It's really good that you can run it standalone, so you can debug, test, see the performance before you package and send to the other side.
Okay, so the build does still output the normal Xcode project, and you have to just grab the stuff you need from that? Or is it like in the Unity build window, you have to click build as a library?
No, it's seamless. You just build. Just press build, it outputs for you ready. So then the Unity framework is inside the Xcode project. If you use Unity as a library, you just need to embed this. It's just a drag to the Xcode on the other side.
Okay, thanks.
I was wondering, how much does it add to the size of the app to just include this framework?
Yeah. So the empty scene project adds to your final binary only 64 bits, of course, 25 megabytes on the best case that we saw so far. Thank you.